Today we're going to be talking about two-step equations and how to solve them. So a two-step equation is similar to one-step equation except it has more than one step. So we know that we have to use inverse operations when solving one-step equations. And we know that the inverse of addition is subtraction, the inverse of multiplication is division. But with two-step equations, you're going to be using more than one inverse operation. And there's two types of two-step equations that we can see. And we're going to focus today on just one of those types. So two simple rules. So let's write that down. There are two simple rules to follow when solving two-step equations. Okay, so we'll talk about the very first situation, or the first scenario. So scenario number one, you've got what looks like a coefficient with a variable, like 2x. You're adding or subtracting with a constant, and it's equal to a value. So 2x plus 3 is equal to 23. So in this situation, the very first step that you would have to do to solve, so step one, in order to solve it, you're going to perform the inverse operation to the constant. So inverse operation to the constant. And remember, the constant is just the number that you're adding or subtracting. So basically, you're going to add or subtract first. So if it's an addition problem, you're going to subtract first. If it's a subtraction problem, you're going to add first, whatever that inverse would be. So add or subtract first. So let's take a look at our little problem that we have here. So we've got 2x plus 3 is equal to 23. Since our current operation that we see here is addition, we're going to utilize subtraction. And remember, we have a nice little wall that we've set up between our equal sign so that we divide our left half and our right half. And we need to keep both halves balanced. So if I'm subtracting 3 on the left side, I need to subtract 3 on the right side. And remember, adding 3 and subtracting 3 is as if it never even happened. So we can go ahead and cross that off. And then all we're left with on the left side is that 2x. And on the right side, we now have 23 minus 3, which is 20. So we're left with 2x equals 20. Now we're down to a single step equation that you already know how to solve it. So that's what step 2 is. You're going to perform the inverse operation on your coefficient, or if you happen to be divisor or dividing, you'd perform it on the divisor. So the inverse operation to the coefficient or divisor. So that basically means you're going to multiply or divide. So in this case, since the problem was 2x is equal to 20, and we see that 2x is multiplication, our inverse operation is going to be to divide. So again, we've got our little wall here. We would divide both sides, and remember, a fraction bar is the same thing as a division sign. So 2 over 2 means 2 divided by 2. Those would simplify out, so I can cross that off. Then I'd have to do the same thing on the right side. I'd have to do 20 divided by 2. I have to divide by 2 on both sides. In fact, let me go ahead and write that off to the side. I'm going to divide by 2 on both sides. Just like up at the top, I subtracted 3. So I'm going to subtract 3 from both sides. Okay, so we subtracted 3 from both sides first, then we divided by 2 on both sides second, and that gives us our value. X is by itself, and 20 divided by 2 is 10. So there's our answer. X is equal to 10. Okay? So let's go ahead and take a look at another practice problem. So if I give you 2n plus 5 is equal to 13. Again, the first step is to perform the inverse operation to my constant. My constant is this plus 5. So I'm going to subtract 5 from both sides. So minus 5 here and minus 5 here. If you need to set up your wall, do so. Okay, the plus 5 and the minus 5 are going to cancel out. Now left with 2n is equal to 13 minus 5, which is 8. Now I'm going to divide by 2. So again, set up your wall if you need to. We're going to do 2n divided by 2, and we're going to do 8 divided by 2, because we're trying to get n isolated. We want n by itself. So 2 divided by 2 simplifies out. 8 divided by 2 is going to give us a 4. So we have n is equal to 4. Okay, anytime that you need to have the video paused, you can ask the substitute to do so, and he'll pause it. Okay, let's take a look at another practice problem. We've got 8 plus x over 4 is equal to 17. So again, we're going to focus on the constant, and the constant is the value, the number value that's being added or subtracted to the variable. So that would be the 8. The 8 is our constant. Now that plus sign here belongs to the x plus 4. Remember we talked about that when we were talking about simplifying expressions. We said that it's the sign or the operation is what's in front of it, not what's behind it. So right now, 8 doesn't have anything in front of it, but because we know that this is a positive number, I'm going to go ahead and put an imaginary plus sign right in front of it. So that to me lets me know, hey, I know it's positive, so it's almost like there's a plus operation in front of it. It's different than this plus sign that's behind it, because that plus sign belongs to the x over 4. So the inverse operation of this positive 8 would be to subtract 8 from both sides. And we'll do a problem next that is very important for you to understand the difference between what's in front and what's behind. So here we're going to subtract 8 from both sides. These 8s will go ahead and cancel each other out. Now I'm left with a positive, because this is a plus, I'm left with a positive x over 4, and that's equal to 17 minus 8, which is 9. Okay, now since this is division here, remember a fraction is the same thing as division, x divided by 4, the inverse operation here is to multiply by 4. So we'll multiply both sides by 4. I'm going to do 4 times x divided by 4. So multiplying by 4 and dividing by 4, they will simplify each other out. But whatever I do on one side, I have to do the other. So I'm going to multiply 9 times 4 as well. Now I've got x by itself, so x is going to be equal to 36. And guys, anytime that you want, you can always plug this in and check to see if you get the correct answer. Alright, so let's take a look at another problem. Number 3. Let's say that we have 20 is equal to, say, 5 minus 3n. Now, again, I know that this is a subtraction sign here, but that subtraction sign does not belong to the 5. So if you were to say, oh, well, hey, the inverse of subtraction is to do addition, if I were to add 5 to 5, that would not cancel out. 5 plus 5 is 10. My goal is to get rid of the 5. So that 5 actually has a little imaginary plus sign right in front of it, because it's indicating that it's positive. Since that 5 is positive, my inverse operation to the 5 is still subtraction. Remember, that subtraction sign does not belong to the 5, it belongs to the 3n because it's in front of the 3n. So we're actually going to subtract 5 from both sides. When we do 5 minus 5, that's going to cancel out. And then we're going to do 20 minus 5. Well, 20 minus 5 is going to give us 15. So now we have 15 is equal to, this is really important that you understand, that minus sign has to come down now. That minus sign comes down now and it acts like it's a negative sign. So now instead of minus 3n, it becomes a negative 3n. So we have 15 is equal to negative 3n. Okay, this is multiplication, so the inverse of multiplication is to divide. And we're going to divide both sides by a negative 3. Because we want to get n by itself, meaning we have to get rid of the negative sign as well as the coefficient. So we'll divide both sides by negative 3. So negative 3 divided by negative 3 simplifies to a positive 1n. So n is now isolated. And then 15 divided by negative 3 is going to give us a negative 5. So we get negative 5 is equal to n, or n is equal to negative 5. Either way that you write it is perfectly acceptable. So I'm going to go ahead and write down a few problems for you guys to try on your own to make sure that you've got a good handle on it. So here's problem number 4. We'll have 19 is equal to negative 3x minus 8. Problem number 5. U divided by 6, or u over 6, minus 12 is equal to 3. And then problem number 6. 8x minus 2 is equal to 22. So right now, go ahead and get those problems written down. And if the substitute could please pause the video so that the kids could work on it. And then once everybody seems close to being done or is done, then go ahead and unpause it. Okay, so if the sub has unpaused the video, then you're probably ready. The first thing that you should have done here for problem number 4 is add 8 to both sides. This would simplify out by canceling the minus 8 and the plus 8. You're going to add 8 over to the 19 as well. 19 plus 8 is going to give you 27. So you have 27 is equal to negative 3x. And then the last step is to divide both sides by negative 3. And then you'll get x is equal to a negative 9, because 27 divided by negative 3 is negative 9. You could have also written negative 9 is equal to x, and that's perfectly fine. For problem number 5, your first step is to add 12 to both sides. Minus 12 and a plus 12, again, will simplify and cancel each other out. You're left with u divided by 6 is now equal to 15. And then your last step, instead of dividing by 6, you're going to multiply both sides by 6. So 6 over 6 would simplify out, and you'd be left with u is equal to 90, because 15 times 6 is 90. Alright, and then the last problem, problem number 6, you're going to add 2 to both sides, because the inverse of subtraction is addition. So that minus 2 and that plus 2 would simplify out. They'd cancel out. You're left with 8x is now equal to 24, because 22 plus 2 is 24. And then you're going to go ahead and divide both sides by 8. So 8 divided by 8 is going to give you x, and 24 divided by 8 is going to give you 3. So you have x is equal to 3. Okay, so we'll go ahead and wait until Tuesday to look at scenario number 2. Finish with the notes, and then I want you guys to work on the worksheet that the sub is going to hand out to you. Please keep in mind that the expressions paper that we did on Friday, the one with the word problems, how to translate one-step equations into, or one-step word problems into equations, that is due tomorrow, as well as the worksheet that the sub is handing to you right now.